We've played with circuits.io and have simulated an Arduino. Now we're going to actually touch an Arduino and hook up some LEDs to it. So go back to circuits.io and dig up your LED circuit. Build a document that links to it, or rebuild the circuit that you see. Use a 330 ohm because that's what's in your kit. Let's look at the code as colored by circuits.io. The brown, the stuff that begins with a double slash, forward slash, is a comment. INT means integer. So it's specifying the number of bits that the variable LED will hold, and it's putting the number 13 in there. Void setup is a function that's done once. Void loop is done over and over and over again. The delay 1000, the 1000 in blue, is 1000 milliseconds. So that's exactly 1 second. And what you might want to do is play with those two. If you keep them both the same, then it'll be half on, half off. What we really want to do is fiddle with it in the real world, not in this virtual world. So the Arduino code's broken down into 3 sections. At the top, in the red circle, you see the initialization of the variables, defining their type and putting in initial values. Then you see setup. This is telling the Arduino CPU, it's an AmpDel CPU, how to think about some of the wires going into it, whether data is coming in or data is going out. And then the purple down there, the purple circle, is the loop that's done over and over and over again until you turn the power off to it. So what is syntax? Syntax is the purple and the black stuff. Arduino syntax up there is INT, void, pin mode, output, loop. No, not loop. Not loop. That was named by the programmer. Digital write, high, not LED. Delay, digital write, low. Those all came from the Arduino programming language. What was set up by the programmer was LED and 13 and 1000. Functions in here, let's see, void setup. Setup is the name of the function. It's being described there. Void loop is the name of a function. It's being described there. Pin mode is a function that's being used. It's being evaluated. Digital write is a function that's being evaluated. Delay is a function that has 1000 milliseconds associated with it, and what it does is delay 1 second. So what is a function? Well, in math, a function is something like f of x equals x plus 2. And then we say, okay, what if x equals 3? So we evaluate the function. So there's 2 steps. One is you define the function. The second is you evaluate it. So the same thing's true in a program. In Arduino, we have a function called f. I'm describing this function as an integer. And then in the parentheses, I'm saying it's f of x, and x is an integer. And then on the other side of the equal sign, I'm going to say that's going to be a result, and that's an integer. The result is equal to x plus 2, so that's just like the math up there. And then I'm going to return the result. So you can see over here, on this side, you can see Arduino evaluating that function. So we're going to make a random integer variable called random name, and then we're going to say random name is equal to f of 3. So this 3 gets passed to this x, right? 3 plus 2 is 5, and then the result, this is the result right here, gets shoved into random name. Now random name contains 5. So this is where the function is evaluated, this is where the function is created. Now the Arduino has an integrated development environment, IDE. The primary integrated development environments are Visual Studio, which you'll learn in the ComSci 1 and ComSci 2 here at Howard Community College. The problem is both College Park and UMBC use Eclipse, not Visual Studio. And some students have a hard time switching to Eclipse when they transfer to College Park or UMBC. But all IDEs have the same basic features. They have a workflow. In the Arduino, it's pretty primitive. It's up there at the top with the file, edit, sketch, tools, help, the checkbox, the arrows, and the magnifying glass. The text editor, they all have a good text editor. They all have the ability to display messages, both at compiling time and if something goes wrong. And both Visual Studio and Eclipse have version control for teams. This is associated with GitHub. We don't have that built into the Arduino IDE, but it is built into Eclipse and Visual Studio. Fritzing appears to have an IDE down here at the bottom. It appears to have an IDE, but really what it does, once you configure it so it works, is it calls up the Arduino IDE and gets it to send stuff down to the Arduino. And in the process, you lose some error messages. So let's not use this. So the workflow for the Arduino is you start right here. You find a file in the examples, or you find one online. You cut and paste it into here. And then there are tools. You click on board and choose your board name. And then you go into tools again and choose the port. And then you click on this arrow right here to send it to the Arduino. And then you watch messages here. Basically there's two. The first, it'll be compiling. Second, it'll be uploading. And then there'll be white text down here if everything's good. There'll be red text down here if something goes wrong. Okay, I have my Arduino plugged in. And now I'm going to go follow the steps. So the first step is to find the example code for blinking blink. And the next step is to go to tools and find my board. Okay, my board is in Uno, so it was correctly set, correctly guessed. And then my port is telling me is a COM13. That's actually a USB port. And now I'm going to send it up to the Arduino. So it's going to go from the computer to the Arduino. So it's compiling the sketch right here. This is good. So the green bar is showing progress. Now it's uploading it to the Arduino. The lights are blinking on the Arduino. Now it's done uploading. The light's blinking. And you can see I've got good messages down here. Nothing in red. Everything's working. So what we just showed was testing. We showed the real world circuit and sending the program down and watching the program run. So this is the testing section. Now what we need to do is finish this up in Fritzing. So Fritzing is where we finish off the documentation. We redraw the circuit like we did in circuits.io. But then what we do is we go to the schematic. This is the logical thing that the electrical engineers are going to look at. Then we go to the PCB board, the printed circuit board, and we lay it out. This is actually making a shield, so we can actually send this away and pay some money and get these built, and then stick them on top of our Arduino so we don't need the breadboard anymore. And then we actually, the last section right here is the code. And we can actually store the code with our drawing of the circuit board and our schematic and our printed circuit board. So this is the final summary of our work with the Arduino, and we link to it inside of our team's documentation. You also need to save the code outside of Fritzing and make a link to it. Now, the most common misconceptions are that when you send the code down the USB cable into the Arduino, that you can somehow get the code back. And the answer is no. Once it goes down here, it gets stored here, it's saved here, that's all true. It survives this Arduino being powered off and sitting on a shelf for a year and powering back on. It'll run that program that you downloaded here. But there's no way to get the program back into the computer. You have to save it separately in Fritzing. Now, it is possible for the Arduino to send data back this method, but it's just data. It's information. It's associated with the code that you write. It's your code talking to you. It's used for debugging purposes sometimes. Only the output of the program is going to flow back. Only data is going to flow back through here to this serial monitor. You click on that magnifying glass and you can see the program talking to you as it's running. Sometimes. Depends on how it's written. Okay, so now we're going to do this for the red, green, blue LED. It's one LED with 4 wires coming out of it. This is how I wired it up. So I have a single 330 ohm resistor. You can look at the details here. So this is being done at circuits.io again. The next question is, where do we find the software? Because circuits.io doesn't have the software, and in fact there aren't any examples inside the Arduino IDE for the RGB-LED. So you have to go out on the internet and search. And one of the best places to find code is at arduino.cc. And this is a program called Color Crossfader. So you cut and paste it from the web into the IDE. This is the link to the circuits.io example that you see right here. And now what we do is go through the IDE workflow. So we cut and paste our crossfade code into here. Then we go to Tools and Board and choose Uno. That's typically what we're using. Then you go to Tools and Port, and hopefully it'll detect the serial port for you. It'll tell you that it's Arduino Uno on COM12 or something like that. And you click on the upload arrow and you watch the messages down here. If there's no red error messages, then it's most likely working. And here's a video of it working.
Okay, it looks red, now it's going to blue, now it's going to green, now it's going to purple, now it's going to red.
So the last step is to document it in Fritzing. So once you draw it here and you go over here, you might have to move things around. The goal is to try to get it so the wires aren't crossing each other. Crossing wires are confusing. Like this wire right here that crosses is confusing. This is the printed circuit board. So here are the holes that'll plug into these black holes right here if we pay money and get it made. And then you cut and paste the code into here that's working so that it's saved along with all these others, and create a Fritzing file. So in a summary, there's 5 steps. Draw the circuit at circuits.io. Find the code and simulate it if you can. Document the link in Google Drive. Then build the circuit in the physical world and test using the Arduino Integrated Development Environment. Shoot a video of it working so the next group can replicate your success. Document it in Fritzing in case we want to create a PCB printed circuit board out of it. And transfer the Fritzing file and the INO file up to Google Drive and then link those in.